and welcome you all. This is Professor Rajesh Varapte, a book author of 25 plus engineering books. Dear students, today's topic is I shall be teaching you how to solve numericals using Maxwell's equations. If you haven't yet watched the video related to derivation of Maxwell's equation, do watch it. I will provide the link in the description box. As far as numericals are concerned, you don't have to mug up all the lengthy formulae, all the sets of Maxwell's equation. For maximum numericals, only two equations are required, which I have written, equation 1 and 2. And but derivative formula is quite commonly required, that is dabba by dabba z. Simply derivative of cos beta z is minus beta sin beta z. One integration formula is well required. Integration of cos omega t dt is sin omega t upon omega. Now, let us discuss one numerical. In charge-free region, now do remember this word. Charge-free means it is a free space. So, charge-free region is a free space. Magnetic field intensity is h bar. We know notation of magnetic field intensity is h bar. It is given by hm cos beta z cos omega t ay bar. Ay bar is the direction of h bar. Students, you might have used these notations I, J, K in maths to denote the unit vectors. In this subject, we are using notations Ax bar, Ay bar and Az bar corresponding to I, J, K, which equally indicates the unit vectors. Alright. Now, from the given equation, first step is, this is the given equation of h bar. Only one direction is given. So, apart from given direction, whatever remaining part is there, that means this part, it is denoted by hy. Very simple, only one direction is given. So, skipping this direction, whatever remaining part is there, that is denoted by hy, h to the base y. Why h? Because this is the given equation of h bar. Suppose the direction would have been given as az bar, I would have write here, it is hz, like this. Alright, so this is the component hy. There are basically two more components hx and hz, but hx is 0 and hz is 0. How I wrote directly these two equations? Very simple, only one direction is given. So hx is 0 and hz is 0. Now I will tell you very simple trick. As I said, only two equations are sufficient. So first equation is del cross E bar is minus dabba B bar by dabba T. Second is del cross H bar is dabba D bar by dabba T. Question arises, out of these two, which equation I need to use and why? Listen carefully. What is given? Equation of H bar is given. While deciding the formula, always think of LHS side. So look at LHS side related to H bar. I have this equation number 2. So I am going to use equation number 2. Alright. So I will write the equation, that is del cross H bar is equals to dabba D bar by dabba T. Recall the notations. H bar is magnetic field intensity, D bar is electric flux density, and we know the well-known relation D bar is epsilon E bar. Since it is a free space, charge-free region is a free space, it is written as D bar is epsilon 0 E bar. Alright. Now, look at the LHS side, del cross H bar. I need to express this LHS side in terms of determinant. How to do it? I will write over here, del cross H bar is equals to, I am writing this equation in terms of determinant. Now, in maths, you have used I, J, K as the directions. In this subject, we will be using notations Ax bar, then Ay bar and Az bar. Here I am supposed to write dabba by dabba x, then dabba by dabba y and dabba by dabba z. Derivative with respect to x, y and z. Here I am supposed to write values of hx, hy and hz because I am writing this equation for del cross H bar. So this determinant I will have to solve. Now, before solving, I need to put values of hx, hy and hz. Directly I have written the equation of del cross H bar in determinant form. We discussed hx is 0, hz is 0. So I will delete this term. I will write 0 for this term. What about hy? Just now I explained you. Hy, we will get it from the given equation. So value of hy is hm is some constant, cos beta z cos omega t. That's what I did. What I did, first I selected equation number 2. Why? Because h bar is given. As I said, only consider LHS side. So I'm writing LHS side in the determinant form. I got this equation. Look at the formula of Maxwell's equation. This LHS side is equals to d bar by d bar t. Now I need to solve this determinant. I hope you are aware of solving this determinant. Still, I will explain how to do it. While solving this determinant, I will have to write like this: ax bar in the bracket. I am considering this ax bar. So everyone knows the rule. Skip this row, skip this column, then this into this. That is d bar by into 0. Naturally it becomes 0. Then d bar by z into this term. What I have to do while considering x bar, I will have to skip this column and skip this row. So this into this becomes 0. Then derivative d bar by z, that is derivative with respect to z of this term. So I will write like this: 0 minus d bar by z of this term, hm cos beta z cos omega t. This is about the direction ax bar. What I did, I skipped this row, I skipped this column, this into this minus this into this. So I got this equation. Second term, for this term, everyone knows I need to put minus sign, minus ay bar. Again in the bracket I will have to put the values. Same rule, skip this column, skip this row. So you need to take this into this, that is 0. Similarly, d bar by z into 0, it becomes 0. So I am writing 0. Next term, plus az bar. Again, skip this row, skip this column. Now, d bar by x into this term. Do remember, d bar by x is derivative basically. Derivative with respect to x, but there is no x term. So unnecessarily don't write the terms in while generating the equation. So d bar by x, that is derivative of this equation with respect to x, will be 0 because there is no x term. So I am directly writing 0. Similarly, what I did, I have skipped this row and this column. This into this, that is 0. Second term, d bar by into 0. Naturally it is 0. So this becomes 0 is equals to RHS side. I am keeping it as it is, d bar by t. Very simple. Now, these terms are 0, so I don't have to consider these two terms. I need to do the calculation of this term. You just have to calculate the derivative of hm cos beta z into cos omega t. As I mentioned, hm is the constant. We are taking derivative with respect to z. So again, hm and cos omega t are constant as far as derivative is concerned. That means I can take it outside. Now you need to take derivative of only this term, cos beta z. I have written the formula. Derivative of cos beta z is minus beta sin beta z. So simply put the values. So I will write the new equation, ax bar as it is, 0 minus this derivative is minus beta sin beta z, and as I said, hm and cos omega t are constants, so I am keeping it as it is, hm cos omega t. These are the constant terms. Remaining terms are 0 is equals to d bar by d bar t. As usual, let us further simplify it. Minus of minus becomes plus, so this equation can be written as ax bar, this minus become plus. I will rearrange the terms. I will write it like this: hm beta minus become plus. I have taken hm at the beginning, sin beta z into cos omega t is equals to d bar by d bar t. Now, what is asked in the question? I need to calculate value of E bar. This is the equation I got for d bar by d bar t. First, I need to calculate d bar because we know the well-known formula. D bar is epsilon 0 E bar. Once you will get d bar, you can well calculate E bar. So first task is I will have to calculate d bar. How to do it? It contains derivative sign. So simplest technique is whenever you want to cancel out derivative sign, take integration on both sides. So I will integrate this equation. I need to take integration of both sides of this equation. For the simplicity, I will take this I will transfer this RHS term at the LHS. That means if I want to integrate it, I will write it like this: integration of dA bar d bar by dA bar t with respect to dt. I have written this RHS term at the LHS, and this term I will write it as it is: integration of ax bar in the bracket hm beta sin beta z cos omega t. Integration is with respect to dt. Now I have to perform the integration. Just now I mentioned, if derivative sign is there and you are taking integration, this integration and derivative gets cancelled, so only d bar is left at the LHS. At the RHS, keep in mind you are integrating with respect to t. Only term corresponding to t is cos omega t. So all these terms, that is ax bar, hm beta, sin beta z, are constant. So first I will write these constant terms: ax bar, hm beta, then sin beta z. I have written as it is because these terms are constant. Now I have to integrate cos omega t. I have written the formula: integration of cos omega t with respect to dt is sin omega t upon omega. So this term I am writing it as sin omega t upon omega. What I did, I have performed integration of only this term. Remaining terms are constant, so taken out, and I have directly written answer of this integration. This is the equation of d bar. Let us try to write it in the standard format. Standard format means for every equation the direction should be written at the end and constant should be written at the beginning. So I will write it like this: d bar is hm beta. I will also transfer this omega at the beginning, so it becomes omega sin beta z sin omega t. Now last step, we discussed, we have this formula: d bar is equals to epsilon 0 E bar. E bar is electric field intensity, d bar is electric flux density, epsilon 0 is permittivity of free space. From this equation I can write E bar is d bar upon epsilon 0. Just now we have developed the equation of d bar. We want equation of E bar, so just divide this equation by epsilon 0. So final answer is E bar is equals to hm beta upon omega, this term as it is I have written, divided by epsilon 0. So I will write epsilon 0 over here, and remaining terms are as it is, that is sin beta z sin omega t. This is the equation of final answer of A bar. So the procedure is very simple. As I said, 90% cases you are supposed to make use of these two equations. So to get an idea, I have solved one numerical and it is E bar. E bar is electric field intensity. I hope you are aware its unit is volts per meter. This is the final answer. Now let us solve one more numerical to get the idea in detail. One more thing before solving the next numerical. We have forgotten to write the direction. It is ax bar, so I am supposed to write it at the end. So it is ax bar. Here also I will mention ax bar. Now let us discuss second numerical. Numerical is in the free space E bar. E bar is electric field intensity. It is given as 20 cos of omega t minus 50x. Direction is a by bar. Calculate ZD bar and H bar. ZD bar is displacement current density. First we will complete this calculation. So basic equation of ZD bar is d by dt of d bar. D bar is electric flux density. But we don't have equation of d bar. What is given? E bar is given. We know the well-known formula. D bar is epsilon 0 E bar. So to get d bar, I need to multiply this equation by epsilon 0. So this term I can write it as d by dt of epsilon 0 into 20 cos of omega t minus 50x ay bar. 20 and epsilon 0 are constant. Derivative of cos is minus sign. So I will write minus sign over here, minus 20 epsilon 0 sin omega t minus 50x ay bar remains as it is. Keep in mind we are differentiating it with respect to t, so consider this term only. Now derivative of cos is minus sign, that's what I have written. I have written minus sign at the beginning, and it contains omega t. We are differentiating it with respect to t, so this omega should be taken out, so it is written like this. Final answer can be simply written as minus 20 epsilon 0 omega sine omega t minus 50x ay bar. Now this is the equation of ZD bar. ZD bar is displacement current density. Since it is a current density, its unit is ampere per meter square. We have to do the calculation of H bar. This is the given equation of E bar. How to correlate the things? Look at the given equation. Given equation is equation of E bar. We have two Maxwell's equation. As I mentioned earlier, consider only LHS term. So in the first equation, at the LHS, E bar is existing. So I will be making use of first equation, which I have written over here. Now, given direction of E bar is AY bar. So skipping the direction, remaining value is the value of EY. What about other terms? EX and EZ are 0 because there is no term related to direction, AX bar and AZ bar. Now I have to write this LHS part of equation in terms of determinant like the previous sum. So here initially I will be writing EX, then EY and EZ. As we discussed, we have only EY term, that is 20 cos omega t minus 50x. So EX is 0, this term is 0. In place of EY, I have to put this value 20 cos of omega t minus 50x, and EZ is also 0. Now I have to solve this determinant. How to do it? So first term AX bar in the bracket. If I am considering AX bar, skip this column and skip this row. This into this becomes 0. Then dabba by dabba z of this term. See, this is derivative with respect to z of this term. This term don't have any z term, so it is naturally becoming 0. So I will write it as 0 minus 0 minus ay bar, second term. While considering second term, as usual, skip this column, skip this row. So dabba by dabba x into 0 is 0. Dabba by dabba z into 0 is 0. So I will write it as 0 minus 0 plus AZ bar. While considering AZ bar, I need to skip this last column and this row. So calculation will be dabba by dabba x of this term minus dabba by dabba y of 0, which is 0, but I need to consider this term. So it is dabba by dabba x of 20 cos omega t minus 50x. Second term is 0, as we discussed. Dabba by dabba y of 0 is 0. That is equals to RHS term minus dabba b bar by dabba t. This term, I have written it as it is. Now I need to simplify this equation. So first terms are 0, so I am not considering it. This AZ bar remains as it is, this term. We have to take derivative. 20 is constant. Derivative is with respect to x. So consider this part only. Now we have to take derivative of cos term. So derivative of cos is minus sign. So I will write AZ bar, then minus sign over here, that is minus 20. This 20 I have written it as minus 20 because derivative of cos is minus sign. So I have considered this minus sign over here. Sine of omega t minus 50x. Do remember, you are differentiating it with respect to x, and the term related to x is minus 50x. So I need to multiply this by minus 50, which is equals to RHS term, that is dabba b bar by dabba t. No, I need to further simplify it. This minus sign and this minus sign becomes plus. 50 into 20 is 1000. So I'll write it like this: AZ bar into 1000 sine of omega t minus 50x is equals to minus dabba b bar by dabba t. But what is asked? It is asked to calculate h bar. First we will calculate d bar. Like the previous sum, I need to integrate this equation. So we'll perform the integration and we'll write this term at the LHS just for the simplicity. Just for the simplicity, I will write this term at the LHS and I will transfer this minus sign. So I will write it like this. Integration of dabba b bar by dabba t. I haven't considered this minus sign, is equals to minus az bar into 1000 sine omega t minus 50x, and I have to integrate it, so I will put integration sign over here. Integration is with respect to t. Now I need to solve this integration. So as we discussed earlier, integration and derivative sign gets vanished, so at the LHS I will be getting only term b bar. This minus az bar and 1000, these terms, I have taken it outside the integration. Now consider integration of sine omega t minus 50x. Integration is with respect to t. So integration, do remember one simple formula, integration of sine omega t is minus cos omega t upon omega. So for this term, I will write this integration as a minus, then cos omega t minus 50x upon omega. Let us simplify it further. This minus sign becomes plus, so I will rearrange the equation as 1000 upon omega cos omega t minus 50x, and direction I will write it at the end, that is az bar. This is the equation of b bar. But what is asked in the question? It is asked to calculate h bar. We know the well-known formula. B bar, that is magnetic flux density, is mu 0. Mu 0 is permeability of free space into h bar. Therefore, h bar is b bar upon mu 0. So final answer can be written as h bar is 1000 upon omega mu 0 cos of omega t minus 50x az bar. This is the value of h bar. Now h bar is magnetic field intensity. So that's what we did, the calculation of h bar. Dear students, I have tried to simplify the equations and I have explained you how to solve the numericals using only two Maxwell's equations. So if you want more solved numericals, do let me in the comment section. Till then, thanks for watching this video. Thank you. Bye.